So okay guys, so we are going to continue from where we left. All right, so in this question, tutorial 3, question number 6, we were told that the initial velocity is 46 meters per second and the angle at 35-degree angle. So we want to calculate the time it took, the flight time until it reached here. Okay, that is the line. And we know the normal parabola, when this is the initial height, it must come back to the ground. But in this case, it had to move until it reaches this height. Since it's a parabola, you know it's symmetric. This height can also be obtained at this height. Okay, so at this time we can obtain the same height, and also at that time we can also obtain the same height, which is 5,5 meters. So before we obtain these times, we find what are the values of these times. We are going to first find the components. Whenever you are given an angle and a speed and an angle, you must split that vector, which is the speed v, into components. Okay, you must split it into components. So the components which we are talking about, you want to split in the x component, and also you are going to split in the y component. So the one which you use whenever you talk of y, displacement in the y, you are always using the value of the y component. When you talk of displacement in the x, change in x, you use the x value. You don't use 46, but you use the x component, okay, as the initial. And whenever you use the y, v initial is not 46, but it will be v sine of what? Of 35. Always x is a cos, and always y is always a sine. All right, let's go. So where are we going to start? We are going to start here. We're taking upwards as positive, which means we have taken upwards as positive, which means our g, acceleration due to gravity, this one which they normally refer to ay, acceleration in the y, is going to be negative because we have taken upwards as positive. But if you take downwards as positive, this will be positive. Okay, so we must note that. So our final velocity in the y, which means vyf, okay, here the final velocity in the y is equal to the final the v initial in the y. So the final velocity in the y at this point is equals to the v initial in the y at that point squared plus 2 multiplied by a, which is that, multiplied by the change in what? In y, which is the distance above the initial point. So this change in y, it's always above the where it was initially projected. Okay, so this is the change in y which you are looking for. Okay, so we want to calculate what time did it take for it to reach there. Okay, so when we calculated, we substituted the value of vyf, which means the final velocity in the y direction. So we are talking of the final velocity in the y because this is a two-dimensional problem. So you must specify whether is it in the x or it's in the y. So this is the final velocity in the y direction. Squared is equals to the velocity in the y initial, which is the velocity in the y initially at this point. It's 46 sine 35. You square it, plus 2 multiplied by acceleration, which is that one. Okay, you plug in there. What is your change in y? It's above the point, above, which means it's a positive. But if it was below, it's a negative. So here it's above. So which means I put 5,5 positive. So when you simplify the right hand side, you are going to get 588.34. Okay, so you want VF, so which means you are going to square this number. So the square root of that will give you this. So your final velocity will be at this point. So this is the final velocity in the y direction. Okay, there should be a final velocity in the y direction, not vf, but in the y direction. So it must be specific, it must be this one. Okay, y direction, it must be 24.26 meters per second. All right, so now we've got the final velocity in the y. We want to find the what? The time. That is what we want to find now. So we have the final velocity in the y, but we want to find the time. How do we get the time? And which equation of motion are we going to use for time? And remember, this was our VI in the what? In the y. And this is our VF, and this is our acceleration. So the final velocity, we use which equation? Which equation did we use to find this time? So that is the equation which we used. Okay, we used the final velocity in the y is equal to the initial velocity in the y plus acceleration times time. By making t subject of the formula, you come and substitute. It's going to be the final velocity t. It will be what? Final velocity. Can you see what is happening there? Push everything. The acceleration, it's negative, which means when it comes to the left, it becomes positive. So you push Vy to the right, it becomes what? Negative. That is the negative part. So At is equals to Vy minus y initial. Then you want t, which means you divide by 9,8. So I just took this, I push it this side, then I took Vyf, I push it to the right. So at the end we'll be having y initial, which is that, minus this, which is 24.26 divided by that. Then you get 0.217 seconds. So at 0.217 seconds, you can see it's somewhere there. I'm not there. Okay. That is the bad part of this kind of method. It only gives you one answer. It does not give you two. But you must know that whenever they asked at this height, it occurs twice. Okay, it occurs twice. It's only this one which occurs once, the maximum height, but any other values, they occur twice. So we must have two times, the time in the first one and the second time at the same height. Then you can see which one are they referring to. Okay, so the best approach was to use this one, this method, which will give you time as a quadratic expression whereby you have two values of time. So once you have two values of time, then you can see which one is bigger, which corresponds to where you want. You can see the bigger the time, therefore you'll be at a far height. Okay, so we come again, we use this formula, change in y in the y. We are not in the x. So the change in the y, remember, we must use the y component. If you talk of the change in the x, you must always use the x component. So the change in the y here is that one, 5,5. Then you plug it there. It's a positive because it's above this point. It's above. If it was below, then you put a negative. So positive 5,5 is equals to Vy initial times time. What is the Vi initial? It's 46 sine 35. 46 sine 35 multiplied by t, plus half, that is your half, multiplied by acceleration. Taking up as positive, acceleration is 9,8, negative, multiplied by t squared, that is the t squared. Okay, now we want to put it in the form of quadratic equation, whereby an equation is equals to 0. Okay, so that we can use the quadratic formula to solve for t. So let's see how we did it here. We have 5,5. Okay, so this is a negative, then we push it to the left, it becomes positive. That negative becomes positive when we push it to the left hand side of the equation. So half multiplied by 9,8 multiplied by t squared. This is positive. So if I push it to the left, it becomes negative. So it will be that minus this. And then this remains where it is, which is just a positive 5,5, is equal to, since I have shifted everything to the left, then it's equals to 0. So under quadratic equation, when you're solving for A, B, and C, so you have your value for A, you have your value for B, you have your value for C. So your A is positive 9,8 times half, your B is negative 46 sine 35, and your C is a quadratic, it will be 5,5. So solving this quadratic equation gives you t is equals to 0.217, or t is equals to 5,5 seconds. So now you must come and decide on your own which one could be the better time, which will suit the flight here. Can it be 0.12 seconds, 17 seconds, or t is 5,17 seconds? So physics is something which is practically possible. We know that 5 is greater than 2, so definitely 5 is somewhere there, and 2 is here. So definitely the flight time it took from there up to there, it was 5.17 seconds. Okay.